there, welcome to Siddig's channel. If the children were here, we would call it Siddig Squad, but it's just Siddig's channel. So I just did a video on long division with a remainder. I apologize, it was a little chaotic because the boys were a part of it and they always create some chaos. So we booted them for this one. This is synthetic division, so I'm going to show you how to synthetically divide when you're able to. And then we're going to talk about how division relates to the remainder theorem and the factor theorem. All right, so synthetic division only works, or I should say works best, or really should be used when your divisor is to the first degree. And what I mean by that is, if I'm dividing by x minus 5, that's okay to synthetically divide. If I'm trying to divide by x squared minus 5, that's not okay to synthetically divide. Okay, so this number here should be 1. A 2 makes it so that it doesn't work. A 3 would make it so it doesn't work. There are ways that you can finagle it when the powers get bigger, but it's not consistent. So I don't generally recommend it. You really are best off using a first power. Especially because really once you practice long division, it's not nearly as horrible, and you don't have to use it nearly as often as you can use synthetic division. So I really recommend synthetic division anytime this happens, when you've got just an x minus 5, if you have just an x, you can synthetically divide. If you have a 2x minus 3, you can synthetically divide, because it has nothing to do with any of the parts after. It just is that fact that first degree. Now, this one will give you synthetic division with a fraction, but you shouldn't be scared of fractions. All right, but I'm going to do a synthetic division that does not have a fraction, and it probably will have a remainder. So I'm going to synthetically divide, I don't know. I always go for 3 first, and I don't know why that is. I'm going to go for 2x to the third minus x squared plus 5x minus 7. And then I'm going to divide that by x plus 1. Okay? I just randomly pick numbers. I don't know how they're going to work out. I don't know what's going to happen. All right, my first step is always set my divisor equal to 0. Okay, we're going to talk about with the factor theorem, the reason why when you do this, they call, Siddig, what am I doing with my life? 0. I was jumping ahead. If you test this, what they'll sometimes do is they'll say, is this a 0? And they just mean synthetically divide it and check the remainder, which we'll talk about. But when you take this and solve it down to here, they would call that you're testing a 0. All right, so my first step is to take this lovely x plus 1, that's my divisor, set it equal to 0, and get the x by itself. Now, I've seen actually a couple of different formats for this. The way I learned it and the way that I've always taught it is you use just a backwards kind of L-looking thing and then a line. Some people prefer to do like that. I'll show you, no, that's not the right form. Some people prefer to do that. I'll show you both formats just so you can see that they're the same, and it's really up to you. That -1 is what I'm dividing by, so it's what's going to go here or here, depending on which form you like better. Now, what goes up across the top here are the coefficients of my polynomial. All right, so both places. Just like in long division, if you've learned long division, you have to watch your powers. I have an x to the third power, which jumps to an x squared, which jumps to an x to the first, which jumps to an x to the 0, which just means that the x doesn't exist there. I don't need to worry about a placeholder. But instead of having to use all the x's like I do in long division, I'm going to steal the coefficients and their signs. Now notice this one doesn't have a number because it exists. It has an invisible 1 there. All right, so I need a -1. I have a +5, and I have a -7. When I learned it, other than the negatives, they never really had you put a sign, but I found teaching it that a lot of times students struggle then when they're doing the downward part, like, is it addition, is it subtraction? So if you want to keep the signs with what you had, keep them, because it'll make your math when you add, subtract, down a little bit easier. Okay, same thing happens over here. I had a positive 2, a negative 1, a positive 5, and a negative 7. All right, now your first term always drops. All right, you don't do anything to it, you just drop it below the line. So this one also will drop below the line. Now, anything below the line is going to get multiplied times the 0 that you're testing. So negative 1 will multiply times 2. Negative 1 times 2 is negative 2. That answer needs to go below the next term. What you're doing is like shorthand long division. So you're really saying, okay, x goes into 2x to the third 2 times, but then 2 times negative 1x squared would give me negative 2. That's what this is. Now, because they're both negatives, I do an add, subtract, down. Because they're both negatives, I'm going to combine them to be 3, and it'll be a negative 3. Okay, same thing here. Negative 1 minus 2 is negative 3. Now, once again, oh, and these colors, you can't tell them apart. I don't know why I'm doing that. Multiply. Okay, now we're going to multiply to the next one. Now, when I do synthetic division, I don't actually draw these little arrows, but if it helps you to remember that this is the part where you're multiplying, you can always drop them. I don't put them there because then I'm like, oh, I got all these arrows everywhere and it makes me grumpy. All right, so negative 1 times negative 3, that's going to be a positive 3. Same thing here, negative 1 times negative 3 is a positive 3. Once again, it goes above the line because it's going to combine with this 5. 5 and 3 will make 8. 5 and 3 will make 8. All right, now for the last term, I go ahead and I do my last multiplication. Negative 1 times 8 will give us negative 8. And now negative 7 minus 8 is negative 15. So I'm technically done with the problem, but what I have to do is I have to write it as an answer. And this is also where the idea of the remainder theorem comes in. So notice it's the same form. I'm just going to erase this one so I have a little more space. When I divide this thing by this thing, this is my answer. It was to the third power. I've divided it by a first power, so this answer has to be less power, right? I've divided and I've taken the power from it. So this 2 is going to have an x, but instead of being an x to the third, because I divided, it drops the power to x squared. Now the minus 3 gets an x, because you go down in power. The 8 is just a plain 8. And that negative 15 now is my remainder. And to show that I divided it, but I didn't get a whole piece, I put it over what I divided by. Now, what the remainder theorem says is it says you can take this part here times what you divided by. So you would say, okay, 2x to the third minus 3x plus 8 times x plus 1 minus the remainder. They just call that the remainder form. Okay, what it does is it says this is the answer I got after I divided by this, and this is what was left over. Okay, now the remainder theorem, and I'm going to do this same problem with the remainder theorem. The remainder theorem is an option to use when you don't need to divide, you don't need the full answer. All you want is to see, is it divisible evenly? So is it a factor? Or you want just the remainder. So this one is not an even dividing, because if it was, this would end in a 0 because it would have divided perfectly and I wouldn't have any leftover bits. The remainder theorem can test that for you. The way the remainder theorem works is you take your original polynomial. So I would take my 2x to the third minus 1x squared plus 5x minus 7, and I plug in the 0. All right, so x plus 1 equals 0. I subtract my 1, x equals negative 1. I'm now going to test, before, remember I said they call that a 0, is it a 0? I'm going to test that 0 in here. What that means is, every time I see an x, I'm going to replace it with negative 1 and see if negative 1 was a 0 for, or that x plus 1 was a factor of this problem. It's frustrating, even to me as a math teacher, It's like I get why they have so many words for it because they're used in kind of different scenarios. But when you as a student are learning them, if you are a student as learning them, it's really confusing because this is what you synthetically divide by. You can call it a 0 if the remainder is 0. You can test to see if it's a 0 by synthetically dividing it, or you can test to see if it's a 0 by doing the remainder theorem. Okay, the remainder theorem is substitution of the attempted 0 into the original polynomial. All right, -1 to the third is -1. If you're not sure, you can always use a calculator, but negative times negative times negative stays negative. Okay, -1 squared is a positive 1. 5 times -1 is -5, and then I have -7. 2 times -1 is -2. Negative times 1 is -1, minus 5, minus 7. Well, -2 minus 1 is -3, minus 5 is -8, minus 7 is -15. Same thing. That's why they call it the remainder theorem, because instead of having to synthetically divide, you can do the remainder theorem and get that same remainder. That helps you test whether it's a factor. So I'm going to quickly show you what it looks like when it is a factor and which one is the factor and which one is the 0. So I'm going to go very, very basic. Let's say I've got x squared minus 25 divided by x plus 5. There are two ways that you could be asked a question. Well, there's more than two ways. But you could be asked, is x plus 5 a factor of x squared minus 25? You would do the same process as if it said, is -5 a 0 of x squared minus 25? Okay? Here you get the full factored term. Here, they already set it equal to 0, and they're testing the 0. So you can do this either with synthetic division, or you could do this with the remainder theorem, and I'll show you both methods. Now, I have to admit, I chose this one because it's easy, but also because I'm going to need a placeholder. So first step is x plus 5 equals 0, subtract my 5, I'm testing -5. Testing my 0 to see whether x plus 5 is a factor. So I put that in my backwards L, or if you like the other form, I have a 1 in front of my x squared. Notice I'm missing an x term, so I have to put in a placeholder, and then I have -25. I drop my 1, -5 times 1 is -5, 0 minus 5 is -5, -5 times -5 is positive 25. If my remainder is 0, then this is a 0, this thing right here, or you could say that this thing right here is a factor. All right, it really, you're testing the same thing, it just is two different words for it, because usually when you're talking zeros, you're looking at the graph, where the graph hits. If you're talking factors, you're usually talking about dividing it or factoring it. Now, I keep losing my eraser. I will also show this to you in the remainder theorem form, which is I'm going to plug that -5 in to my original. So my original was x squared minus 25. I'm testing the polynomial of -5. So is that a 0? I take -5 squared. I replace the x with this number. -5 squared is positive 25, and 25 minus 25 is 0. Notice I get the same remainder in the remainder theorem as I got when I synthetically divided. I would get the same answer if I long divided. I would get the same answer if I tabular divided. All right. For me, this is the idea that the more options you have, the easier it is to find one or two options that make the most sense to you. Okay, so the factor theorem says it's a factor if its remainder is 0. The remainder theorem says you can test that by plugging it into or substituting it into the original polynomial. But if you forget how to substitute it in, you can always synthetically divide and still prove, yeah, it has a remainder of 0, so it's a 0, or depending on how you're thinking about it, it's a factor. My brain really hurts now, and I'm very tired. I hope this made sense. I hope it wasn't too fast. All right, but it's kind of a lot to describe in one video, so I hope that was as simple as I don't know that was simple, but hopefully it makes sense. All right, Andrew would tell you to subscribe, even though he's not here right now. All right, if you like the video, I don't know why you would, I mean, no offense to my channel, but I don't know why you'd be that excited to like a math video, but you can always like a math video if you want. Subscribe though, because that way if you have things you want me to cover, or you'll get an update possibly, or you can always subscribe, and then that way if you're like, oh crap, what was that lady's name that taught math and I need to relearn math, you will still be subscribed to me and you can find me. All right, thank you.